Fred, can you hear me? Can anyone hear me?
I can hear you, Ron, loud and clear.
Yes, we could hear you.
I'm here.
Okay. And I will get the meeting materials and open a share screen. Okay, how do I open a share screen?
Hey, Ron and Fred, sorry to interrupt. Just wanted you all to know that chat is down right now. jabber.ietf.org is experiencing an outage, so chat's not going to work until that gets fixed and it's being investigated.
Okay, I saw that email. What
Okay.
I'm looking for is the tool to open a share screen.
So it's the little
Here it is.
thing that's next
Publish
to the
screen.
hand. There we go.
There it is. Okay, and can you guys see my screen now?
Yes, we can.
Okie doke. Fred, can you hear me now? Fred is on mute. Okay, we'll start out, and the very first thing I'll do is, let's see, show you the agenda. You can see that?
Yes.
Okay, we're going to have a talk from Ramesh at Reliance Geo about his deployment experience, and then we're going to discuss 4 internet drafts. And let's see. I should show you the note well, if I could figure out how to do that. Let's see. Hang on just a second. Okay, can everyone see the note well slide? Can everyone see the note well
Yes.
slide? Okay,
Yes.
note it well.
So we can see.
Okay, excellent. And now we will ask for a note taker.
I can help.
Okay, who is that?
This is Shu Ping from Huawei. Hi, Ron.
Okay, thank you very much for taking notes.
Yes, but I may need a helper because I will also do the presentation. And by that time, I hope another person could help.
Okay, do we have somebody who'll cover a second note taker? Okay, I'll take notes during your presentation. Okay, Ramesh, are you with us now?
Yeah.
Yes, I see you're online. You can unmute yourself.
I guess, yeah. Somehow I have a difficulty in starting video.
Oh, can you see your slides now?
Yeah, I can see my slides.
Okay, can everyone else see them?
Yes, we can see him.
Okay, Ramesh, take it away.
Yeah, sure. Hi, everyone. This is Ramesh Chandra from Reliance Jio. Today, we are going to share our experience on deployment of IPv6 in building the greenfield IP telecom network infrastructure. Many of you, if you're not familiar about Reliance Jio, quickly in couple of seconds, we started commercial network early 2016, and almost we have completed 4 years. In 4 years, today we are carrying highest number of mobile subscriber on IPv6 globally. That is a stage what we have done. So in these 4 years, we are going to share in couple of slides what was our journey, what we did it, what is the strategy we followed, what are the challenges we face, how we work upon them, and what are the open areas where possibly we also look for industry impact mode to support both from not only standard bodies and also from the OEM community. So I'll just move to the yeah. So in this discussion, I guess we have a 15-20 minutes time to cover this in fact more 10-12 slides. So we're going to talk about strategy, what is the present status of the IPv6 deployment, and the challenges we just briefly talked about, and what are the solutions which we think are possible, and what is that support which we need. Now, briefly, if we talk about 2015, when we started building a new organization for providing 4G services, we had options like, what do we start with? Should we start with IPv6? Should we start with the dual stack? We start with the traditionally the way IPv4 being deployed. And then we had a couple of thoughts, in fact, like this market where even not only a network, telecom network infrastructure, even we have to look at the complete ecosystem, device market, applications, network infrastructure. So all these components put together need to decide what is the right strategy we need to follow to start with. And of course, this is the open market. India is a completely open market where subscriber decide what devices he is going to use. Okay, and then the device has to work in operator environment. So environment here a little more challenging than even other geographies which we see. Even the some of the services where the home device is also provided by operator, that is well comparatively little easier. Highly price sensitive because even the income grade group of the people highly impact more slightly comparatively lower. So people are very sensitive to any extra price which they pay even to the operator. And then IPv6 in 2015, it was very at early stage, and even application provider, whether it is a OEM community, even the devices side, it was not very mature, so it was very early stage. Similarly, when we are working for applications, even the CDN providers, they are also building the dual stack network. So what we started at that stage, maybe it is not right to push IPv6, okay, to begin with. So we adopted, okay, dual stack is the option to start with. While we start dual stack, IPv6 only is the right direction forward. So what we did, we set the directions inside the organization. Any product and technology we select, we have to be IPv6 ready. And no matter how great the product, if it is not supporting IPv6, definitely that is not right the platform, right technology for us to choose. So that is the strategic direction which we mandated within the organization while deciding any product. And that is the reason, even after starting implementation, even today, we see whole of the network, we see even IPv6 ready. Let's go to next slide, please. Yeah, I can do that. So in this 4 years of journey, what we see is like, for a voice over LTE, the VVM services, depends on the device type. So based on the tracking area code, we assign IPv6. So all the devices we support, in fact, voice over LTE, when signaling, data plane services, we assign IPv6 only. So what we see in the network today, almost 90% of the devices okay, we assign only IPv6, okay, for the voice over LTE services. There are still like 10% devices where there are certain devices challenges, which we'll talk about in subsequent slides. So 90% it working only on IPv6 line. On the network infrastructure, if you look at, like, whether the E-node V, the small cell, outdoor small cell, indoor small cell, access point, okay, utilities, all various complete network infrastructure, it is all IPv6. When we talk about management platforms, when the devices, router, switches, NMS, EMS, okay, all of them on IPv6. And similarly, when some of the security systems which you have built up, and then to manage securities, okay, some of the SMPS control systems, those are also they are managing IPv6. It is not that okay, all it happens in overnight. Yes, it is a continuous journey. When we started dual stack, quickly we have turned around all these infrastructure from dual stack to IPv6 only.
If I could interrupt for a second. If you're
Yeah.
not speaking, please mute your
We
microphone.
go to next, please. Yeah.
Chat is not working. If you refresh your web browser, it probably will. Obviously not the people actually presenting, but for everyone else, to fix the Jabber chat, if you refresh your screen, that should do it. Sorry for the interruption.
Okay, Ron, you should have audio, do you?
There we go. Okay, Ramesh. Can you folks hear me?
Ramesh, when I did a mute all, I may have muted you. Take a look and see if you need to change that.
Fred, can you hear me?
I can hear you.
Okay.
Okay, I touched mute all with the idea that that's supposed to mute everybody except you and I and the speaker. And I may have accidentally muted Ramesh. If so, Ramesh, you need to touch the mute audio button or the unmute audio button.
I don't see Ramesh here.
He's there. He's after Philip Teasel and before Shuping Peng.
Oh, there he is.
Okay, this is irritating.
Ramesh, can you type in the chat if you can hear us?
The chat might not work for him unless he reloads, as the director emailed a few minutes ago. It certainly is true for me.
Okay, he may also need to be in the queue as a speaker.
I'm not, and I can unmute myself.
I'm sorry?
I am not in the queue and I have no trouble unmuting myself, and I have no special role here.
Okay. That's confusing. Oh, Ramesh appears to have dropped out. And with any luck, he'll come back in a moment. Well, Fernando writes in the chat that he's texting him, but he's not, that doesn't seem to be getting through. Okay, Ramesh is back. Ramesh, unmute your audio.
Hello, can you hear me now?
I can hear you now.
Okay, so I guess I got muted somehow.
Well, yeah, it's probably my fault, and I apologize. You're on, I think, page 5 of your slides. Your current state is dual stack.
Yeah. So can I start it now?
Go ahead.
Oh, thank you. So on the dual stack journey, what we look at it when 4G, LTE, as well as the FTTX high-speed internet services, when the user devices and many of the user devices, wherein there are other devices in T3 mode, maybe at home, where we connect maybe laptop or desktop, okay. And these devices maybe in the T3 are still on IPv4 because of maybe various other reasons. So there is a region on IPv6 for the high-speed internet for the mobile devices. It was found very challenging in fact not to us and only IPv6, because the moment we turn on only IPv6, then we have to use even the CLAT functionality. And then when we turn on CLAT functionality, we have some other various obvious regions. Okay, what are the regions and what are the solution? We'll talk subsequently. So high-speed internet services, that is on the dual stack, which are offering both for the mobile as well as the fixed line services. Many of the applications. So application part of the Geo has not only built up the CDN operator network within our network. These are more popular in the industry, whether it's a Google or it's a Akamai or it's Limelight, and many other. We have also built up our own CDN infrastructure where we have our own application content. So Geo is no more only a connection provider. We have built up complete ecosystem, our own content, and all those content what we have developed on an IPv6. So of course, to support even other subscribers who are coming IPv6, we have to support them. That is where it is on the dual stack. While network infrastructure, it is easier because we have to support IPv4. That is where the NAT we need to really build up, which we can't avoid it. But when you move to the enterprise infrastructure, and in the office, enterprise offices where we have a LAN WAN infrastructure and the applications, so those are still in fact on dual stack, and to support them in enterprise because they have a public contents, and those needs to be accessed from the internet, and that is where continuous requirement of public IPv4 keep coming. And when we go for the OSS BSS, of course, it has to be on the dual stack to support it. Some other things like ISIS, so I guess those are no more the challenges, and it is working. So I feel whole of the, in fact, although major part of the network on IPv6, but majority of the infrastructure because IPv4 is still running on the dual stack. If you look at the Geo Cloud Network infrastructure, what we have built up, and we are providing content even to subscriber, even to the even other subscriber not connected with the Geo. So what we see, number of requests which is served on IPv6 are more than 94%, and remaining we talk about 6% or 5% of the requests which are served on IPv4 are majority of them, maybe more than 50% of the requests which are coming from other operators through the peering or through in fact private peering or public peering which we have. So that is a level of IPv6 implementation, and not only implementation, even the data traffic which we serve on IPv6. Now, while we did this part, now there are a couple of challenges which we experience, and these challenges, for example, if we talk about it, 8% of almost 8% of the chipsets used in the mobile devices do not comply with the CLET, which is RFC 6877. And while we took this in fact cases with the OEMs who are providing mobile devices, okay, and then we come to know there are various other regions. In fact, they also have some business regions where they say the devices and chipset which we use, we are in process of phasing that out, and we have a newer devices which support it, but we don't have compliance by existing device. Now, fortunately, unfortunately, since device is sold to the subscriber in the market, as long as the device is working, subscriber is not going to replace because it is not working IPv6. It really doesn't matter to the subscriber whether we assign IPv4 or we assign IPv6. What matters is that its service continues to work. So that is the reason what we see in the network. Okay, almost 8% of the devices, since they fail on the CLET compliance, and because of this, we cannot move in fact 100% devices on IPv6 only stack. And we have also seen even the SIM which we insert in the mobile device, and for that device in the SIM, to manage the device, we have to pre-burn IP address for the managing the device. And to do that, traditionally, as industry started it, is only IPv4 which is pre-configured in the SIM to manage the device. While we started this exercise, we have make sure all the new SIMs which we have multiple suppliers, we buy the SIM where we burn IPv4 and V6 both, so that anytime we need to manage the device using IPv6, we should be able to reach to the device. Okay. So, but the situation is like, no, these SIMs are in the market. These are with the devices, and if we assign based on the tag code, we assign only IPv6, and the SIM is only have IPv4, then we are going to lose the manageability of the device. That is the risk which we carry without upgrading the profile in the SIM. We really cannot turn on tag-based IPv6 only assignment. So these are the some of the challenges which operator in fact face. It is not a really technology limitation. It is more of a operator environment, because this SIMs needs to be pre-configured IPv4 v6, and even the device is switched off by subscriber, it's keeping at home, and when we decide to utilize it, when it's turned on, then only we are going to push the configuration from the network to update the profile in the SIM, so that it is ready on IPv4v6. And when he's going to do it, okay, how soon he's going to do it, that is always a challenge which we face. So that is the reason we still see we have significant subscriber in the device which are turned off, and we have to wait for them. So the regular cycle goes to keep upgrading the profile. So that is where it takes little time to update that. Go to the next. Thank you. So, well, this is one side. The IoT is another area where there is a highly focused, lot of focus, effort, and the commitments. the two things which is coming very clearly, yes, this is the area where we need to focus, and what we see, there are clearly identified use cases, applications which are ready for the industry to really come up. Now, the challenge what we see is that many of like DVR, NVR cameras which are available in the market today, we did certain analysis and the validation how many of these DVR and NVR support IPv6, and to like surprise that almost like 90% of the DVR and NVRs are only supporting IPv4, and even for them to turn and IPv6 ready, nothing can be done because it cannot be changed by just changing the firmware of the software, because the hardware chipset which is used possibly do not have a dual stack support. So that is one area where there needs to be really focused and come out how we can in fact make that IPv6 ready. Similarly, even the sensors, like whether it is smart metering or any in fact home light sensors, any other sensor for that matter, in fact, have to be IPv6 supporting. Otherwise, if we don't have, then definitely the challenges what we see in the network side, similar challenging will come in the IoT also. And even to enable them, to support them, there could be options where the chipset support only little change in the software firmware can enable IPv6. That is one area. Second is that in case if there is a hardware impact, we know that it may not be feasible, business case may not allow, but at least where there is a change using the firmware, and that is where the change required. And that is what we are driving even with the existing OEMs, where if we can make by firmware change, provided that chipset support, and then let's do and make them ready on IPv6. That is the area where we are working. If we look at this enterprises business, what we look at it, what do we have really in the enterprises? Like the router, there are firewall, there could be switches, there could be some office automation machines, there could be a web server, email server, database, copier machines, vending machine, various other, these are the, like every office has all these systems. And if you look at the today's operating systems, if you look at the today's most of these platforms, okay, what we see are supporting IPv6. So we really don't see that, okay, there is a real challenge in migrating enterprise setup to IPv6. There are very few I can think of. I can't even think of that, okay, these systems are not supporting. Maybe some upgrade is required, new software release is required, but definitely we do have a support. But what we see somehow, we don't see those enterprise houses, they have a priority to in fact bring the change and upgrade the network infrastructure and make from IPv4 to dual stack. They don't see there is a priority, they don't see there is a need, they don't see, okay, we don't see there is a like a drive from them, okay, to make this change and make this IPv6 ready. And in any case, because there is a public IPv4 available, so they don't see in fact we need to migrate to. So that is how enterprise is running even the dual stack today. We did certain analysis on top 10 website of 6 different categories with the sources mentioned below. These top 10 based on their ranking and based on the criteria, we looked at analysis how many of these websites are really working on IPv6, and these are the most popular top 10 website of 6 different categories, where some of these commercial, some of these finance, games, sports. Okay, now we were very excited, hopefully, because industry is moving IPv6. When these websites should also be migrating at least to dual stack, okay, but not IPv6 only. Okay. And what it came to surprise, which is in the next slide, that out of these 60 websites, if we look at it, hardly we see 12 websites which are supporting on dual stack. I'm not able to move. Yeah. Thank you. So if you look at these websites, they are the top ranks website of 6 different categories. And if you look at this commerce and shopping, okay, these top 10, none of them is IPv6 supported. That means these websites are running only on IPv4. And this report is like, we have taken in September. And if you look at even the finance, only one site. Okay. Similarly, in the games, none of the site IPv6. Now we did the same analysis when a year back. Okay, wherein in 1 year, previous year 2019 July, only 11 sites supporting IPv6 dual stack. Now it's 12 sites. Just 1 year, one more site. And if we look at how much time is going to take even to move these two IPv6, the same will take like almost 40 years. And this is definitely because even the web content provider, they don't see the priority, they don't see there is a need to migrate to IPv6. And that is the reason it is extremely slow progress on contents moving to IPv6. Now, some of these, what we think as a possible solution to move from the current, whether it is a IPv4 or dual stack to IPv6 only, the CLET compliant, where we have seen even the chipsets where it is failing, compliance to 6877 RFC. So those chipsets which are currently used by mobile industry, by OEMs, by manufacturing industry, how they can adapt to the chipset which supports. We don't see really driver, but since we being an operator, we really work with them. We try to push them hard though to make sure that at least the devices, the new chipset with the use have a support for the CLAT. And we have got commitment that we are going forward what the device is going to release, they will have a CLAT support. Second is the SIM firmware, where like how we can make the changes from IPv4 to even IPv4 V6 using TCP based connection to the SIM. Okay, so this also requires some of the dependency which you have with the SIM chipset. We are working with the SIM suppliers, and then we're making them, okay, next phase they make sure that they have in fact support with the right firmware so that we are able to make the changes. We don't really bank on the SMS based in fact modification because that is not reliable. In case first SMS goes, it deletes the firmware, and then if the second SMS is not delivered because of any reason, then we lose the manageability. So we really rely on make sure that we do the modification based on the in fact secured communication with the SIM so that we don't lose. The third point is that the MAPT, I think this is also a good initiative by in fact standard bodies by IETF to come out with the RFC and then in fact make this also a feasible option. Now, what we look at it, our view for this MAPT is that since this is a option where we assign public IPv4 along with the port range to every client, and we have to make sure that we allocate the static port range to every client based on the highest number of ports used by any subscriber. Suppose somebody, because he's running some cyber cafe, he has so many clients and he has a big fat pipe, so he has a T-string, so all this we need more number correction. We assign 1,000 ports. So what happens is we end up assigning more number of ports, although it is not used by overall is not being used, but we end up assigning more ports. More port means more IP addresses. So this is not a very efficient way of using the public IP4 resources. But when we compare with any carrier grade net where the dynamic port allocation, we really consume ports and IP addresses based on which are really required. But here it has to be pre-provisioned, pre-reserved. So this is one challenge which we see. It requires that we have to have more IPv4. IPv4 we don't have, we have to purchase from the industry. So it becomes a commercially challenging option to in fact buy additional IPv4. There's one challenge which we see. Second, I guess every country has certain regulatory requirement for the user traceability. And since MAPT, it has a stateful NAT translation on the CP device, where private IPv4 to public IPv4. But on the BR in the network, okay, we have to do from NAT 6 to 4. So again, it is a de-encapsulation, okay, of the IPv6 packet, okay, to IPv4 and sending to the internet. And that is stateless. When it becomes stateless, you are not able to generate any impact on NAT event logs. Now, when the regulator, somebody has done misuse of the services, and where a regulator comes and asks who's that user, okay. Now we provide static mapping based on the IPN port, okay, which we say this is what we have provisioned. That is not entertained by code of law. Code of law says there should be a log generated on the system by the system while user is using your service. That log should be used. That log should say what is the IP address, what is the port number which you use. Since that the BR, there is a stateless, since there is no such log which are getting generated, as a result of this, we find it is challenging to implement MAPT in the network because it does not fulfill our regulatory compliance and regulatory requirements. There is one challenge which we see, that is where we are not able to move even forward. Had it been, if we are able to generate the events, then definitely it becomes a very doable option, leaving that IPv4 inefficiency. Other
Okay,
thing is
Ramesh, you've got a
IPv4
couple
and
of people in the
chipset-related,
queue.
OEM-related
Ramesh?
issues. That is where, yes, we are definitely working, but at the same time, it requires even for the industry to come up to the level where all these new devices which are coming, we have to really control from the source itself. But once it is developed, sold, brought in the market and sold, somebody will buy it. Okay? And when it is bought it, that device has to work in the network. And then operator has a challenge to in fact ensure that device should work. And that is where he has to fall back even from IPv6 to dual stack, dual stack to IPv4. So there is a continuous journey. So all these IPv6 compliant device readiness, application readiness, it has to be really controlled from the source itself.
Okay, Ramesh.
Yep.
You've got a couple of people in the queue. Let me give them an opportunity to ask you a question. Eric?
Yeah. Thank you, Ramesh, for the nice explanation, interesting talk, and nice to see progress since we talked in Paris 2 years ago.
I am not able to hear.
Sorry, I think my audio is working from what I see.
I am not
I can
able
hear
to
you.
hear anything. Not sure about others.
Ramesh, can
Okay,
you hear me?
Ramesh, can you hear me?
Similarly, this screen is also now locked, got stuck, not able to move.
Okay, that's bizarre.
Ramesh, can you hear me?
Does not seem so.
I can hear you fine, Eric. So
Yeah, so do I. I mean, I hear myself, of course, but I hear you as well, Fred and Ron. Okay.
Oh, Ramesh is on mute again. Fred, I take it you're typing to Ramesh?
Actually, no, I'm sitting there.
Oh,
You can hear now. In between, I lost. I could not hear anything.
okay. Ramesh, you had a question from Eric?
Yeah, go ahead, please.
Okay, so as I said, interesting talk, and nice to see the progress you made since we met in Paris 2 years ago or something like that.
That's right. That's right.
I have a question on this CLAB thing and the chipset. I would assume that the client part of the NAT is done in software. So I wonder why the chipset, so for me hardware, has an impact on this.
What is the feedback we are getting from multiples of this? They have used the chipset, and that chipset requires certain programming, and these OEMs, whatever programming they do, they are open, but they say the chipset they have selected cannot in fact use IPv6, and they cannot program this to make in fact dual stack ready. Or the services they cannot make use of IPv6. So that is the one, and we have found many of them. While initially they found many of the devices that it cannot work, and while working with the OEMs, they are able to convert that. We really don't know what level of programming will they do it, but many of them we are able to convert them to make it ready on the CLAB. So then what we did reverse analysis. Let's look at the chipsets. Okay, what we have seen is, if suppose there is a chipset limitation, then if that chipset used by Motorola, by Nokia, by even any other, in fact, now the OEM, then everybody should have exactly the same challenge. There also I found a variation. It is exactly the same chipset. If this chipset is used by, assume for example, a Samsung, it is supporting CLAB. The same chipset is used by Oppo, for example, okay, it does not work. As Carbon, when it inside it does not work. CLAB does not work. So definitely it is, one is the chipset issue. Second is any additional programming which is used by the OEMs, okay, is also making certain difference. So that is the reason. Second part with the OEM, we have the certain commitment that yes, they can in fact make sure wherever they can do it, they will enable it. But others, because of dependency, because the chipset with the use, and they say that device is going to be end of life in the process of phasing it out, they cannot do further investment, and that is where there is no point making the effort. And then that is where we got stuck, and we could not do every dependency on the chipset provider.
Okay. Still kind of strange for me, but I'm trusting you on this one. And if you don't mind, another questions about the MAP-T part, and specifically the NAT logging, basically. Since in MAP-T, part of the translation is done statefully on the CPE, that's basically the same if you do the translation on the CPE towards MAP-T, as well as going from the CPE to another IPv4. So I don't see the difference, because in both cases, the stateful NAT is done on the CPE, where typically you don't have control. Can you comment on this?
Yeah, sure. So what it requires is, yes, CPE can also generate the NAT, which is stateful, and then that NAT may be good enough, but what the challenge with operator faces is that we have millions of devices, we have to collect this log from millions of sources. And for some reason, okay, if I miss that log, and then if there is a misuse, if I miss that log, operator we find difficult to in fact fulfill our in fact obligations and regulatory compliance. So we may have a difficulty in collecting these logs for regulatory requirements from millions of sources, rather than doing from millions of sources. That is where we want to do, because all these devices are unmanaged devices. They are not managed by the operator. They are not in control of the operator. So that is where we bank on the device where we are responsible. We are banking on our own device. That is where we thought, if it is available on the BR, where provided, managed, integrated, controlled by operator, then we really don't have dependency on the millions of these devices. And that is where we have a challenge to use this NAT event from the CP, okay, and taking this log, managing them, it is not very practical because all these are unmanaged devices.
Okay, but I still do not see the difference between the normal, let's say, IPv4 to IPv4 CP. But thank you so much. I'm done. Thank you.
Okay, Jordy, you wanted to get a word in.
Can you hear me?
I can hear you fine.
Yeah, thank you. Actually, my questions were basically what Eric said, but I can say something else about that. The CLAT problem, I think it's not really a chipset problem, and it's more the typical problem of vendors willing to sell a new product instead of solving the problem with firmware or a software update or something. Unless the problem is that the chipset is doing NAT 4.6 by hardware, and then they cannot do, let's say, full hardware process. But considering the performance of the actual CPUs, I don't think that's a problem. It's not really a huge processing capability or creating a lot of battery consumption or something like that. I am not really sure, but I found similar situations in CPEs, and basically it comes to the problem of, as I just said, the vendor not willing to update the firmware. That's one thing. Regarding the MAPT problem, I think it's not a protocol problem. It's more a regulation misunderstanding of how protocols work. And of course, the solution will be go away. If you cannot convince the regulator, go away from MAPT and also use 464X LAT in the broadband. But of course, that will require the CPs to be updated.
Yeah, thanks for your comment. So maybe if I can comment on both the points. One, yes, you are absolutely right on the CLAT functionality and the device. When we use this impact mode translation from 4 to 6, definitely there are additional CPU cycles, additional resources required, and it is going to consume additional power cycle also. So definitely it is required. While we do it, the challenge, yes, because it is something to do with the firmware and the impact mode chipset both. In many cases, as I mentioned before, we are able to in fact fix this CLAT functionality by only changing the firmware itself by the OEM. Many of the cases we have found, even no matter that chipset is used in any of the OEM coming, and everywhere we found the same problem, and that is where OEMs have come back very clearly that we cannot fix this problem because of dependency. Whether they are 100% accurate or they have something else which you are trying to avoid the rework, which you have also mentioned that they don't want to invest effort and money in reworking on this, and because that product is moving toward the end of life, so there is a reason they don't want to invest. Where you are right. We also have exactly the same experience. They don't want to invest something which is not very long lasting. So that is the one reason which we see. Yes, that is right. Coming to MAPT, my understanding, yes, there could be little variation change in the regulatory requirement in different countries. But in normal circumstances, like in 95% of the cases, okay, there is no problem, okay, everything works well, whatever the log we get. But when the typical cases happen, some major incident happens, okay, in any country, like even in India also happened, there is a Taj hotel impact attack, okay, by terrorists. In such cases, okay, the mapping which we provide is not really entertained by the code. What code says, we need, okay, the log which should certify that, okay, this event is generated by this specific user. System at that moment where timestamp should say it is generated by that user. Okay, mapping doesn't work. A mapping table which we give it doesn't work. It is a static information which is available. And if you remember, deterministic NAT, which came in the industry almost 6, 7, 8, 10 years back, that did not go forward because of the same reasons, regulatory reasons. So similarly, that is where we find even the MAPT also. That it works in 99% cases, but operator cannot take a risk when one serious issue or serious incident which happens at that time. It is the operator, in fact, license at a stake if we do not maintain and provide the right information to the regulator. That is a challenge which operator face. But I appreciate your comments.
Okay, Lorenzo, go ahead and speak. I'm going to ask you to be quick. Lorenzo?
Forgot to press the button. Sorry, forgot to press the button. Just wanted to say for 464X lat, I think if you're talking about Android, there's performance requirements in the compatibility definition document that say that the device must be able to do IPv6 only on mobile networks. So that's something where you can tell that if an OEM has an implementation that doesn't work, you can point out to them that they're in violation of the compatibility document. And I'm also curious about these chipsets because Android does have a software implementation of 464X lat. In fact, it has two. One of them is in pure software, and the other is accelerated using BPF because it performs much better. So I'd be curious to hear, maybe privately, what problems you're seeing with these, because this is supposed to work.
Okay, Fred, how are we doing on time?
Well, we're now 53 minutes into a 24-minute talk. So, and of course, part of that has been technical issues, a good part of that. And we're on slide 12 of a 19-slide talk. Ramesh, the information you're giving, I think, is very good and very useful. And so go ahead and speak to your slides, but I need for you to power through this because we've got 4 more talks behind you.
Yeah, sure. So other, I think 2-3 slides what we considered may not be exactly related to IPv6 only. What we also see, like timing and synchronization. For example, even industry today, wherever they are providing, in fact, feed and frequency for a TDM LTE operator network, they are using 1588v2, the default profile. G.8275.2 has also come up, and there is multicast profile which is a 275.1 is also ready, and that is also option available. Now, definitely that multicast, it is full on fast support, and in between, if there is any device that is not supporting, we cannot really use it. And the way it is implemented 1588v2, we want to really, in case if we have an option to go with a 275.2, we don't see there is a PTP currently supported on IPv6. It is only on IPv4. So there is one area what we see possibly need attention, how we can make, in case if industry is really looking at to move from and deploy a 275.2, then definitely PTP or IPv6 required. Even for 1588v2, and when other set of operators, they don't see any reason to migrate and they are happy to continue 1588v2, then also I think industry need that, okay, it should be supported on IPv6. I'm not sure if there is any group, any in fact, somebody, some draft which is somebody is working. So this is one area which we look at. Second is even in the network, for example, we have implemented 1588 V2 in hybrid mode. Every router acting as a BC in hybrid mode, providing in fact phase and frequency to the slave below. And assume that link is of 110 gig, and for business reason have to upgrade their link from 110 gig to 2 into 10 gig, and we have to create a in fact bundle, okay, and we have to use LSCP as a protocol. So as of today, even PTP over LSCP, okay, in a unique cost profile is not even supported. It is not available. So if we have 1588 V2 in unique cost profile, we can't even really use LSCP. ECMP is another option which is available, but ECMP also has many of the challenges because many of the L2 traffic which we has, and that is not going to be shared. Eric is, I think, in the call, maybe even aware. So that has its own challenges. So what we look at it, yes, if 1588, this 1588 V2 is going to stay in the industry, and we have to increase the capacity, then PTP over LSCP is something which is unavoidable. So this is one area. Second, enterprise business, I think that industry is something which is moving slowest. Okay, and it is not really a technology limitation. That is what we realize and we are aware. But it is more of we don't see really real motivation for them to move towards IPv6. And because their contents, they remain on IPv4, that is where all of the industry has to be pushed back, okay, to stay on IPv6 or on IPv4. So we have to really come out something differentiated, some options, some services like, and those services are available only IPv6. If that can attract the enterprise houses to move IPv6, if that is something, maybe it can work. But yes, it may not really good from a commercial and business reasons. But we don't find any other use case. How do we really motivate enterprise houses to migrate to IPv6? And control plane, I don't think there is a problem because SR V6 is ready now. We are also in process of implementation. If we do it, LDP over V6, in fact, is not really required. So I think we are good to go with the SR V6. Okay, so I have included this slide out of context here in the session. The reason for it, yes, we are working for IPv6. We want to make sure, okay, that we migrate to IPv6 in shortest possible time. But at the same time, the bigger problem which I'm facing is not only IPv6 implementation. Bigger problem is that how we can scale our network, okay, for more subscribers, okay. And if we have to scale network for more subscriber, we are running short of private IPv4s, and we are using like RFC 1918 or 6598. Okay, we have 20 million IP addresses, and we have divided our geo network into 26 telecom circles, and every circle we try to reuse the same IP addresses. We have done it, okay, the one time we have done it. Now in one circle I have more than 20 million subscribers. What do I do? Either I divide that circle in another multiple smaller segment. If we do it, there is additional resources required, there are additional capex required, there is additional complexity required. Okay, we have to get into that. Now, one is that rather than doing it, If we have option to get additional IPv4, which can be used for a private purpose, then I can scale my network in a much seamlessly, much simplification we can bring for operations, and we don't bring any complexity. And that is where we found, maybe I don't know whether it's the right time or still it is not too late. Many of these RFCs where we see like 008, which is like 1122 RFCs mention about all these 127.0/8, only one IP address is used. Remaining is made, in fact, not routable. Similarly, 240 series, okay, 256 millions, again, these are reserved. They are reserved, I don't know for when and for what purpose. Do we really need to keep them reserved, or is there time now to open them and make them available, okay, for the operators to use it? And of course, when the operator to use it, it has to be supported by the OEMs on the platforms. And for them, they need a standards. They need RFC. Okay, what RFC they need to comply to make these IP addresses routable in the network. Then only operator can use. So we are really facing a much bigger challenge in managing the private IP addresses, and we have shortage of private IP addresses. And that is where in various one or two other occasions, even with the APNIC, we raised this concern, okay, and really don't know, is there any really serious effort required to release some of the IPv4 for private use? And if this is enabled, I think we have much better scalability. It is not that, okay, by enabling this, we are going to slow down IPv6. No, definitely that will continue. But at the same time, it will bring certain simplicity and scalability to operator network by providing additional IPv4 for private purpose. I think this is all about the content which I wanted to cover, and we can have discussion and clarify queries and answers. Yeah, please
Okay.
go.
Okay, thank you very much, Ramesh. I think we're going to have to take the discussion of your talk to the list. So I hope you're on the list and can respond to that or can participate in that. Ron, who have we got next? Is that Fernando?
Yes, I think packets with extension headers.
Okay.
Thank you. Thank you very much.
Okay, so a point to the remaining talks. Fernando, you're one of these. We have just about an hour left, and so we're going to, you've got 15 minutes. Yeah, I apologize for that. But okay, Fernando.
Can you hear me?
Yes.
I can hear you.
Cool. So good morning, afternoon, wherever you are. So I will be providing a status update of this document. This presentation is going to be like very short, hopefully. What is this document about? Well, it's a document that provides an overview of the operational and security implications of IPv6 extension headers, and it tries to document the reason for which some operators may drop packets that contain IPv6 extension headers. Next slide. Okay, so this is a summary of the changes that we have incorporated into the latest revision of the document. Essentially, we added a background information section where we had been told that for some people the differences between the differences between the packet structure in IPv4 and IPv6 wasn't that clear, and that it would be good to have a section that briefly compare the structure of the two of the packet structure of the two protocols and their implications. So that's what we did. We also added a section on recirculation And finally, we added sections on firewalls and network intrusion detection systems as two possible devices that might need to resort to dropping IPv6 packets when they contain extension headers. Next slide. So this document, the working group last call for this document was performed and completed on November the 2nd this year. And our take as authors is that it should be in shape to ship. So I don't know if there are any comments, questions.
Gory?
Does that work?
Okay.
Yeah, I can hear you now.
Okay, so thanks, Fernando. And I see the title's got implications in, and to me, that is the root problem I have with this particular draft. I missed the working group last call, but I can respond now or in IETF last call. And the problem I have with it is there are several places where the implications seem to suggest the way the IETF should go forward and operators should go forward. So there are hints that maybe extension headers should be disabled, firewalls should have rules in that prevent them. I'm not sure I'm happy with that. I'm very happy with the document saying that there are observations of this and that this is something we have to be aware of and we have to design for. But I'm unsure the exact wording is perfect. I mean, maybe you've had thoughts on this.
Well, certainly the wording might not be perfect. I have, for the most part, having the editing pen on the document, and well, English is a second language for me, so it could very well be the case that the wording might be improved. If you have suggestions on that, please do send them. They would be of use. And as a clarification, we certainly do not want to, and have tried not to do any kind of recommendation on dropping packets with extension headers. So what we try to do is document the reasons for which some operators drop these packets, but it's not our intent to actually provide advice on on what to do in that respect. We are just documenting the reasons for which, in some scenarios and in some cases, some devices might need to drop them. But it's certainly not a recommendation, to just disable extension headers or drop them.
Yeah,
Okay.
that's what I thought, and that seems very useful. Can I send something to the mailing list after the last call to try and help?
Please. Please do.
Yeah.
Okay.
Thank you.
Okay, if you two work that out on the mailing list, I'll take a look at the final version and then we'll send it on to the IESG.
Awesome.
Okay, then I guess we need to move on. So thank you very much, Fernando. So who do we have speaking? Is this Giuseppe?
Yes, Giuseppe.
Yeah, it's Paolo. It's Paolo.
Paolo, okay.
So, can you hear me?
Yes.
I can hear you, yes.
Okay, good. So, Paolo Volpato, Huawei, and I will be presenting on behalf of the authors. So, next slide, please. So, let's start from the motivation for this draft. So, basically, we have seen a new interest around IPv6. There is, for example, a new white paper by ETSI that, let's say, discuss the advancement in IPv6 deployment, some best practices to move it on even further. So we decided to bring, let's say, this topic in the IETF, having two targets. So basically, it's investigate if anything is missing, let's say, for a global acceptance of IPv6, And second, to provide arguments to improve the deployment strategies for both operators and the enterprises. And as a side effect, we'd like also to provide an updated status of IPv6 today with respect to papers such as the RFC 6036 that is probably 10 years old. So the draft has the target of also discussing the incentives for having IPv6 and clearly also presents and investigate the challenges. So what's remaining? Next slide, please. This is the table of contents, and by the way, you see some items here are highlighted in bold. We are going to discuss that in a minute in the next few slides. If you recall RFC 6036, there is a, let's say, something quite similar to that. So it's a sort of a refreshed version of that paper. Next slide, please. Right. There are a lot of analytics worldwide available for IPv6. The white paper of ETSI I just mentioned provides the full list of references. We have put here just a small subset to give a rough indication about the status of IPv6. So we can see from the number of users or, for example, from the allocations that IPv6 has grown quite well, I would say, in the last 5 years. And what is most important, it has grown more than IPv4. So this is a good, let's say, signal to the industry. Next slide, please. Now, when preparing the white paper, we also, let's say, developed a short survey to be distributed to the operators supporting that effort or involved, let's say. So you see the list of questions we posed, for example, the plans to move on with IPv6 in the next 2 years, or what's the favorite technology and other information useful to, let's say, understand the status of IPv6. The draft also discusses the answers, but basically just to, again, try to figure out a rough indication of IPv6 and the real world deployments. You see that, for example, operators tend to adopt a dual stack as the first approach to IPv6. And then when the conditions are, let's say, are good enough, they move to IPv6 only, and there is a slight preference for XLAT in the mobile space and dual stack light for fixed services. So I think I'm echoing here some of the information provided by Ramesh in his presentation. Next slide, please. So there are also incentives that could move forward the adoption or the deployment of IPv6, depending whether you are in an ISP or in an enterprise. These incentives can be different, of course. There is a technical, let's say, list of incentives. For example, somebody in the survey responded that it's thanks to the endorsement of IPv6 from IETF or other bodies that there is a, let's say, a new wave of adoption of IPv6. There are also business incentives or lack of business incentives that foster, let's say, the deployment of IPv6 or, let's say, try to create hurdles to that deployment. And then clearly, there are also government or regulation incentives. Next slide, please. Right, and here we come to the what we refer to as the call for action. So what are the challenges that we probably need to face to have a full adoption of IPv6 and create, let's say, the conditions for the acceptance in our industry? Again, depending whether you are a part of a service provider or enterprise, the motivations may change, so the scope could be different, but actually we found some areas, for example, the transition choices. There are technical aspects to be faced and to be solved to have the deployment of IPv6. For example, for a service provider, there is the issue of having CGNet and the transition to move forward this technology. For enterprises, we have found that some of them, or I would say many of them, have failed to adopt IPv6 because they think it's too complex. They don't have the expertise in-house to do so. There are management issues. So I'm not repeating something that Ramesh has presented already in his talk. So next slide, please. Then there are also operational aspects. So you see, for example, performance. We know that IPv4 and IPv6 are not the same thing, yet people tend to compare them. And looking at some well-documented cases, there is a lot of literature about that. We have seen that on average, if we take the, let's say, a rough average, IPv4 is still probably faster than IPv6. So latency tends to be higher for IPv6. There are some documented explanations for that, number of studies. And again, if you take our draft or the ETSI white paper, we have the full list of references to dig into the matter. Packet loss, EPNIC, for example, has documented that there are some figures about the IPv6 packet loss, packet drop, and that figure is probably worsening over time. So there is a slight increase of packet lost from 2016 to 2020 over the, let's say, the big internet. In terms of performance of the equipment, we have seen that more or less routers are capable of handling both IPv4 and IPv6. Probably there is only one slight difference if we consider the low-end routers. Next one, please. And then the last aspect, so the last challenge is security. Again, something is probably related to what the respondent to the survey associate to the level of complexity of IPv6. So as such, there is probably the misunderstanding that security has to also face to solve that level of complexity. There are clearly issues related to the protocols themselves. For example, we can differentiate between the bunch of basic protocols and all the components that may affect security. There is the list of associated protocols, so ICMP, neighbor discovery, and so on. And the third level of internet-wide IPv6 security, so everything which is associated to filtering, the denial of services attack, transition, and whatever. Specifically, it appears that neighbor discovery and the first hope protocols are part of the area related to security that we need to still need to analyze to give a proper picture. So next one.
Well, Paolo, before you go ahead, Ramesh would like to comment.
Please.
On the slide, when we talk about the latency, what we understand, our experience is that, yes, it may be true for a slower link where the bandwidth is lesser and it is congested. And because of the IPv6 header, which is in fact now much higher than IPv4. Now, if this is congested link, then yes, there is a possibility that latency may be little higher. But assume, for example, in the network where there is no bandwidth limitation, there is no congestion, and in that situation, IPv6 should be faster than IPv4. So latency should be lower, because even the routing platform, if the datagram which is sent, which IPv6 can carry a larger datagram, the number of packets to be processed will be smaller. And if this is smaller, lesser CPU which is going to use, then router is going to be in fact consuming lesser time. And this is going to save little CPU cycle, little extra time which can save, which possibly can compensate even the propagation. And the propagation is like, it is just a speed of light, it is optics. It really doesn't matter with IPv4 or IPv6. So I feel in a good bandwidth where there is no congestion, there should not be increase in latency for IPv6.
Sure, thanks. So there are a lot of studies that I would say proves either arguments. So I will be happy to share what we have found, so we can stay in touch through the mailing list, and so let's say share the materials. So look at the references we have, and I'm pretty sure you can also contribute with your arguments to the draft.
Yeah, sure. Thanks.
Thank you. So just to complete the presentation, very quickly, this is the second part about security. There are, let's say, reasons to, let's say, continue this analysis over the security related to the extension headers, fragmentation, oversized IPv6 packets. So I'm not, let's say, detailing this slide. Let's move to the next, please. Now, what's missing? Basically, the questions we want to share with the audience is the effort we are trying to elaborate exhaustive? Is there anything that is missing in our analysis? What actions can we do? Can we elaborate to further stimulate the IPv6 adoption? And this is specifically true for enterprises. I mean, both areas have been covered in the draft, but probably enterprise is, the domain where we still need some more contributions. I mentioned the survey in the draft, but any further input or feedback is welcome. And for enterprises, just to, let's say, mention that INTC and the Indian Internet Engineering Society are two organizations working on, let's say, the enterprise domain. They have also received 2 grants, one from ERIN and the other from EPNIC, to help with the deployment of IPv6 in enterprises. And you can contact Nalini, which is one of the authors, or Dhruv, to have even more information on that. And last slide, please. So we are really ready to receive a feedback from the working group. You're welcome. Your comments are mostly welcome, and clearly the draft is also open to other contributors. And I would say this is it from me.
Okay, well, thank you very much. And I think we're going to have to take the comments to the list, and people who want to comment on this, drop a note to the list. And I will drop a note indicating how to reach INTC and India, ISOC, or yeah, ISOC. Shuping, did you want to get in? Oh, okay. Yeah, you want to make a presentation. So, yeah. Okay, let's move ahead to Shuping.
Hi, this is Shuping from Huawei. And I would like to discuss about the processing of the hop-by-hop options header. First, about the motivations. And we know the IPv6 is being widely deployed, and more and more IPv6-based new services are being proposed. And the hop-by-hop options header is being taken a very valuable container for carrying some information to facilitate those new services. And among all the extension headers, IPv6 extension headers, the hop-by-hop options header actually possesses the very desirable behavior, that is the hop-by-hop processing behavior. And for some new services, they include IOM, alternate marking, pass MTU. Those work are actually recently adopted by the IETF. However, we know that the hop-by-hop options header is rarely utilized in the current operator's network. That is because the hop-by-hop options header has been taken as a potential DOS attacker. And the operator is basically want to protect this their control plane from the undesired traffic. And we had some discussions in the mailing list of the 6-man working group. We can see that people have various view on this topic. So our purpose is quite simple. So the main purpose is to enable the hop-by-hop options header to be utilized in a safe and secure way without endanger any operation in the current operator's network. And we want to ease the deployment of the new network services in a multi-vendor operator scenario. Next, please. And here are some examples of new services. I'm sure we all know about them. So the IOM, and in IPv6, the hop-by-hop options header is taken as one option. So in that case, it can perform the IOM per hop. And for the alternate marking method, it's the same. And for the minimum pass MTU, that is also a recent work being adopted in the 6-man working group. So they all have the valuable, they are all valuable, they have the valuable cases and very interesting use cases to the operators. Okay, so now I will start from the modern router architecture as specified in the RFC 6192. And we can see that there is a strict separation between the control and the forwarding plane in a router. So the control plane basically is generally is realized in a software on a general purpose processors. And they are responsible for running the routing and the management functions. And they are very vulnerable to the DOS attack. For the forwarding plane, is generally they are realized in the high performance ASICs, all network processors. They are capable of handling very high packet rates. So in between, there is the interface. So generally, there will be a rate limit mechanism implemented. And for the purpose of protecting the control plane against the undesired traffic and against the DOS attack. So that is a good thing, but there are also side effects. It will cause the inconsistent packet drop because of this rate limiting, and that will impact the normal IP forwarding, not even to support the new services. Next, please. So now let's look at the common implementation. And so on the right side part, and that is the specification in RFC 8200 that defines the format. And we can see, so actually in the common implementations, the value of the next header field in the IPv6 header is actually the only trigger for the default processing behavior of the hop-by-hop options header. So for the common implementations in most of the devices in the market, that is, once the device receives a IPv6 packet with its next header field set to 0, it will be directly sent to the slow pass without even examining the option tab. So, and also in most cases, Such processing behavior is a default configuration and cannot be reconfigured. There are some historical reasons for this. So by the time when hop-by-hop options header were designed, the hop-by-hop options were not very well understood, and there are few services. And also in the hardware, the ASICs were not so capable as they are today. And again, there are some consequences, and we can see it now. As I described before, so all the packets containing hop-by-hop will just be dispatched to this slow path, the control plane. That will cause the DOS attack on the control plane. And the read limit will cause inconsistent packet drops. And also, since there are a lot of routing and management functions running there, they are very critical. So if the slow path is congested, so other functions will be failed. Next, please. And we have the specifications in RFC 2800. It defines that it only examines and processes the hop-by-hop options header if explicitly configured to do so. However, there is no explicit specification or recommendation of a given configuration or route to implement. And currently in this specification, and it states that the nodes may be configured to ignore, drop, or assign the packets with the hop-by-hop options header to the slow path. And that we can see, it is the common implementation that will have the problem causing the packet drops. So we would say this relaxation in the specification actually led to the current situation. I wouldn't use the problem here. And here is the very simple diagram I showed in a multi-vendor operator scenario network. And you can see this is a service path. And we can see there are various configurations and operations in the operator's network. And there will be enabled to support the service deployment along the path and without disturbing the normal IP forwarding. And also, more often, very often, this default configuration is embedded, cannot be reconfigured. And we have to admit that the deployment in the network will not be changed within one day. So the devices will be there for quite a long time. Next, please. And now, let's see the operator's typical processing. Actually, it's quite simple. Most of the operators just simply deployed ACL at their network edge to discard all the packets containing the hop-by-hop options. That has been reflected in the few RFCs. And you could see they reported the status in the field. And the hop-by-hop options will be simply, the packets with the hop-by-hop options will be simply ignored, dropped, or sent to the slow path. And many operators will perceive these hop-by-hop options to be a breach of the separation between the forwarding and the control plane. And so what are the consequences? So it's also stated in the RFC 8200. And the new hop-by-hop options are not recommended just because these uncertain behaviors the operators are going to have. And so in that case, the usability of these hop-by-hop options is limited. Next, please. Thank you. So it seems that we are actually facing an endless loop. That is starting with implementation choice, and which causes the hop-by-hop to become a DOS vector. And because the hop-by-hop is taken as a DOS vector, the network operators will deploy the ACL and that discuss the packets containing hop-by-hop. And because operators doing this, And then the network designers just stopped defining the new hop-by-hop options. And because of this, the community wasn't motivated to fix the problem. So shall we break this endless loop? And we would like the community to fix the problem and make the hop-by-hop options actually being utilized in the operator's network, so we can enjoy the hop-by-hop capabilities. Next, please. And here, just a few points to show the desired processing behavior. And we would like to discuss with you and get feedback. And the first principle is the control plane should be protected from the undesired traffic. So that is, the hop-by-hop options that are not supposed to be processed by the control plane shouldn't be sent to the control plane. And also, the hop-by-hop options header shouldn't be directly sent to the control plane once the packets are received. And the second recommendation is that it's better to separate the two types of options that are supposed to be processed by the control plane or the forwarding plane, respectively, because the desired processing behavior for these two types of options are different. And also, the options aimed for the control plane are better not to consume the forwarding plane resources. And yes, so we know that for the current implementation, all the options are sent to the control plane, and also there is no simple way to differentiate the two types of options. And also we have to consider the deployment. And I think we all know, we all want to deploy our proposed RC in the real network. And the new deployments should be compatible with the existing deployments, since there are a lot of devices in the current network. Their default configuration cannot be reconfigured. And also, we have to wait. They will be there for quite a long time. Okay, that's all. Thank you. And basically, we would like to have more feedbacks and discussions and your views on this this topic. Thank you.
Well, yeah. And one of the things that propelled me to put this on the agenda, or propelled Ron and I to put this on the agenda, was that Bob Hinden, chair of Six-Man, said that Six-Man wanted our comments. So I'm going to invite people, whoever they are, from the working group to comment to the list about your draft so that we can formulate a response back to Six-Man. And obviously so that you can see the comments as well. And that's obviously going to be offline. We're not going to be able to do that today. So at this point, Ron, I think we have one more draft, correct?
Yes.
Oh, okay, sure. Thank you. Appreciate it.
Okay, thank you very much.
Hi, this is Gian. Can everyone hear me?
Yep.
All right. So I'd like to present this draft. So it's Slack with variable prefix length, a problem statement. We have had, I think, over the last week or so, quite a number of email threads related to this that spawned quite a bit of interest. So thanks, Ron. So from the first set of threads, I guess that came about, Ole had graciously put together a list of options to extend /64. So of those various options, the two that we're going to talk about in this slide deck is V1, which is 64 share, and which is the option that Cameron had mentioned, I guess, and it spawned quite a number of threads related to how 64 share could be used to extend 6/64 for mobile 3GPP. And then option H in this list here, variable slack. So that's really the problem statement really that we have referenced in this slide in the draft, and the problem that we're stating here. So that's basically H. Next slide. So this slide basically states the problem statement that's described in the draft, and it's really basically extending the further segmenting a /64 that's received from the 3GPP from the WAN, and extending it down to other devices within the network. And there are various different scenarios. A vehicle-to-vehicle scenario where you receive the /64 from the cellular, and you have other downstream devices that you want to segment. And there in the draft, it does describe a couple different scenarios where in the vehicle-to-vehicle scenario where you have different link types of, like, some devices maybe on Bluetooth or whatnot, or different device types, and you want to extend that /64. But the problem is because the /64 is not has that fixed boundary, you're not able to extend. So what this draft does is describes that issue, that if we were able to have a longer prefix length, allow and not have that fixed 64-bit boundary, you would be able to take that 64 and extend. And as shown here in red, like 65s down to devices kind of further segmented down into the customer network. Next slide. So this is the 64 share V2 scenario that was discussed by Carmen, that he had brought up. He had put together an updated version of the 64 share draft. So this was an interesting method of, I guess it was called trickery, of how you can take that /64, but somehow extend, go with shorter prefixes. So I think that the tricky part with 3GPP, that because it does not support DHCP-V6, you're not able to get shorter prefixes. But with using 64 share V2, with 64 share, the concept, you're stealing you're basically doing RAPD and stealing the WAN 64 and using it and subtending it down to devices within the customer edge. So with that, I think with this memo and this draft update, it would request 3GPP to change their requirement to allow any prefix size, so less than 64, to be advertised from the 3GPP gateway via RA to the handset device, the mobile device. So for example, a 56 or even smaller, shorter blocks, if possible. The caveat here is that in order for that to happen, I would think the A flag would not have to be set in the RA for that to happen, or with that A, that would fix that boundary at that 64-bit boundary. So that's I guess one caveat. The other caveat is how the trickery that would work on the 3GPP side is, would they be able to, without having the RFC updated to support, like RFC 4291, which has the 64-bit IAD requirement, fixed boundary. My guess would be that would have to be updated, as well as the 3GPP architecture to support the shorter prefix lengths. So that's something. So I think this could be a possible solution, but it would require, I guess, updating of the of RFC 4291, as well as the 3GPP architecture to support shorter prefixes. Next slide. So the second issue related to that this draft talks about regard to the problem statement and why longer prefixes should be allowed, and is in regard to the addressing architecture, and then really the three methods of addressing. One is static, the second DHCP-V6, and then of course the third Slack that we're talking about now. So static allows for any prefix lengths, 0 through 128, and so does DHCP-V6. Slack is really the only one that's lacking that does not allow for that. So in this draft, RFC 6164, the previous version of this, I guess historically, /127s on point-to-point links was harmful, and the reason for that was due to the overlap with the router anycast IP. So with this draft, this RFC, it actually states that it is recommended, and vendors, I think there was a bug in router hardware that caused a ping pong effect to happen, that it was not supported, but now it is a recommended, and really it's a de facto standard that most all operators on any point-to-point links, that you do use a /127. Next slide. So in this RFC 6164, what's mentioned is neighbor caching. So how this really comes into play is what most operators do across the board is, even though Slack does not support and it has that fixed 64-bit boundary, what most operators do in IPv6 deployments is they do use, and it's really used across the board, is instead of using a fixed /64 length prefix on any kind of subnet, let's say infrastructure, they do basically a hard limit on the ND cache by actually setting the subnet size to the number of hosts that you have. An example would be, and I got a slide further down, but really an example of that is, let's say it could be a shared, let's say, content engine network, or let's say a firewall, let's say a firewall pool or whatnot, or let's say NFV or virtualization, where you have a pool, but you don't want to have like a massive /64 pool just due to the issue related to ND cache exhaustion that could happen. So you set that hard limit, and it's really based on the number of IPs that you plan to have, or you extrapolate to have, as far as scaling over time, but not a massive /64. Next slide.
Okay, John, can I step in here, please?
Sure.
Shuping, you're listed as in the queue. Is that left over from presenting, or is that a new hand? Okay, I'm going to guess that she has left the, well, she's not around. Lorenzo, you wanted to talk. Lorenzo?
I had a comment to make on the 64 share v2 slide. I don't know if you can put that on the screen. It's a few slides back, maybe 3 slides. Yeah, just a little bit further down, I think. Yeah, no, yeah, that. So
one more down.
One more down.
The next one. There we go. That's it.
Yeah. So you can't do this, and the reason you can't do this is that it will break every unmodified device on the planet, because all the devices out there know that you can only do Slack on 64. If you ever do this by mistake to a legacy device, it'll just not form an IPv6 address. So I think if you want to do this, and there was some discussion about this, I think we have to introduce a new option of some sort in the RA. We can't use PIO for that. We still have to have a 64 PIO for AutoConf to work. Just wanted to note that.
Okay. So Lorenzo, so I think in this slide they were actually talking about, this is with 64 share with shorter prefixes, but I think you may be talking about the slide prior to this with extending and doing longer prefixes, I think. Is that correct? Or
No, what I'm saying is that
the
draft says relax the requirement to allow any prefix size to be advertised by the RA. If you put a 56 in, if you'd advertise a 56 PIO, you'll break autoconf on every existing device, because every existing device can only do autoconf with the 64.
No,
so unless you can.
Understood. So Lorenzo, that's I agree with that. I agree with what you're saying. I think what this would require for this to work is you would really have to update the RFC standard, like RFC 4291. You know, so there would have to be some kind of backward compatibility, but it would require changing the standard to work. I don't think there's any way that it would work, even with, let's say, the A flag not set. I don't think it would work, and that's what you're stating, that it would break everything.
Yeah, it wouldn't work. I mean, I think you can try to define a new option. That I think you can do, but you can't use PIO. You can't use the PIO option unless you can do something like 2 PIOs in the RA. Maybe you could try that, but the host would be probably quite confused. Anyway, I just wanted to say, I think if you want to do this, you'll need a new option.
It would be a new option, and I think in this draft that we're talking about on this with this deck, so that states the problem statement, and there's another draft that talks about a flag that could be used in PIO that actually allows you to have a variable length prefix. And we have tested that, like just on the Linux kernel, with one of the developers that's on the on this draft that states that it can be done. It's just a matter of getting a work group to adopt the one that change the draft, and really the problem statement, and that's really the big one, whether the work group would agree to changing that, and it would be really changing the standard, the RC 4291, break that fixed boundary. And so that's really the sticking point.
I don't recommend that you attempt to change that. I don't think you'll succeed. I think your time is better spent. We had a huge bust up a few years back. It took months, and then we just had a lot of arguments, and then went nowhere. I think you're much better off defining an easy way to advertise a bigger prefix to hosts, like your 60 or 56 here, and basically use that as a replacement for DHP PD, for example, on mobile networks. I think that's got a much greater chance of succeeding in standard space, and even in mobile handset space. It's actually a lot easier, for example, for Android to do this than it is to implement PD for a variety of reasons, some of which technical, some of which non-technical. So,
in this slide here, it actually states that if you didn't have the A flag set on the PIO, could you actually send it? Could the RA send a shorter prefix? Yeah,
you totally can. It's just what the device will just not have an IPv6 address, which kind of isn't what you want. Right? You want it to work.
Right. So it just wouldn't work because the device wouldn't accept it, really, because it's going to try to build a 64-bit. It's not going to be able to work. I guess so. It's not going to be able to do anything with that shorter prefix.
That's right.
Gotcha. Thanks, Lorenzo. We can go back to the other slide. I guess we can continue with the presentation. So where was I? I was on that. I guess go to that ND cache exhaustion. That's kind of where I was left off. Yeah, there we go. So this slide really talks about addressing really and the reasons why. So I think in some of the threads that we had on the mailing list was regarding operations and operators and whether variable length masking is used, and really, so really what the key point here is in this slide is really that it is used, and it's definitely proliferated, kind of throughout. Most operators do use, and this ND cache hard limit, I mean, it's really kind of stemmed from this RFC that it's definitely used quite a bit, and it depends on the size of the host, and this is all static addressing that, if you're dual stacked or even V6 only, that you're sizing the subnet based on the number of hosts that you plan to have on the subnet, and without not having to use any knobs to actually, prevent ND cache exhaustion. Next slide. So in this slide, it actually, yeah, that's okay. Yeah, go to, sorry, let me see here. Go one up, actually. Go back one. There we go. Yeah, I just wanted to mention something that was mentioned in this RFC. So it does mention in here that even if you're doing any kind of careful rate limiting or anything with, you know, like any knobs or tweaks, you know, to prevent the ND cache exhaustion, you know, it may not be bulletproof, and that's really one of the reasons why operators, just to be sure, they don't want to run into problems. So having to size a subnet based on the number of hosts on the subnet has really been the kind of the recommended way of doing it. And it's really because, you know, variable length has been supported, you know, via static addressing, you know, since day one that's supported. So that's really been the mantra of how to address, you know, for operators. Next slide. So this slide, so the RFC 7381, it talks about the enterprise IPv6 deployment guidelines. So go on to the next slide. So in this slide, just pointing out that that /64. So with the 64-bit boundary, it is the recommended that, you know, because you do have, because Slack devices, that they have that fixed EUI 64, so that modified 64-bit boundary. So even though you may have stateful or static, does support, you know, variable length, so any size, it's recommended for any host subnets to use /64. However, anything infrastructure that's statically addressed, you can pretty much use any address, any size. So, you know, from 0 all the way to 127, whatever size, you know, fits the bill, can work. Next slide.
Okay, Gian, FYI, in about 2 minutes, the Meet Echo room is going to close.
Okay, all right. Thanks, thanks. I'll try to wrap it up. All right, the race to the bottom. Let's see if we can race through the slide deck. All right, so so basically on this slide, I'll just kind of try to summarize with regards to the race to the bottom. I think there was a comparison on the mailing list that was done regard to history and NAT and the reasons why. So NAT is, you know, has been there forever, and it's really helped, you know, at least extend the use and even carrier grade NAT to extend IPv4. So it has served its means, you know, to help extend, and it has helped for overlapping of address space. So there has been, you know, need for that, and it has served its purpose. So, and even today, and I think probably until V4 is gone completely, NAT has its place. However, comparing, so the comparison that was done on the mailing list was related to NAT for broadband users. So any in your broadband, you know, users where you're doing a NAT overload, that carriers, you know, and it's been, you know, really the ubiquitous standard that carriers, they'll actually give you get a single IP on your WAN on your broadband interface, and then basically you're doing a port overload, and you're doing a port address translation, port forwarding. So you're really just getting a single IP. So comparing IPv4 to IPv6, you know, it is completely apples and oranges, and there's just no way you can compare that. You just compare to the size and volume of space, and the reason why operators have done this for a reason, that they know that there was even you know 10-15 years ago, because the address space was so limited. Yeah, and that's really why IPv6 came out 20-some years ago, that we knew that address depletion was going to happen, and that's why the ubiquitous standard for broadband was a single IP. So there's absolutely no way you can compare IPv6 to IPv4 to IPv6, and the reason why operators went down to the race to the bottom to give out a single IP is an absolutely not a valid comparison to why V6 would have that same race to the bottom. And just to the case in point there is that with IPv6, you truly have unlimited, ridiculous amount of space, that even with the the 2000/3, there's still unallocated space by IANA. I think there's like 5 other /3s, and there's a bunch more there. So there is a tremendous amount of space that's available. But that being said, another question that came up on list was, well, let's say, if hypothetically, 3GPP or maybe even 5G may be a different story altogether with network slicing. But let's say with 3GPP and 64 share, if we were able to allow, somehow we were able to get a shorter prefix, hypothetically, if you were able to like consider a human allocation of a /48 per human, then that was an idea that came up on list. So just taking that theory, to see if that is even possible given our current schema of address breakdown, and how addressing is deployed kind of on the internet. So when you think about it, when the IANA, when it reserves, you got space that's reserved down to the VER, and then the VER allocates to the ISP, and then you got the end user allocation. So the ISPs, just looking at the ISPs, what they get, in general, the starting points at /32, and this is from Jordy, thank you for sharing kind of some of that information of what, what's the allocation schemas that have, been done by Wright. So let's say 32 by, for general starting point, 24 to 26 for medium, and then 19 to 20 for large. So just given those numbers, and this is just a hypothetical, even if you had a /24, and that's for like a large ISP, that would yield 16 million /48s. And I'm just giving Verizon like as an example. We have 150 million subscribers. There's no way, even with a /24, and that just covers our 3GPP or wireless space and not broadband users. So there's no way you'd be able to cover it, with that amount of space, doing a /48 per human. So granted, you do have a lot of space, but I think you would have to allocate more, further allocate. And there are unallocated space within the IANA that they would have to allocate to do a 48. I think probably a 56 is possible, but 48 per human. Since that did come up on thread, I wanted to talk through that, and that definitely would not be possible. Next slide. So this slide, I just wanted to kind of emphasize, what operators do, just to give 6man and the folks on here really what's done and what's reality and what's deployed by operators. So as far as IPv6 is concerned, variable length masking is there, and it's really proliferated, throughout operators, around the world. /127, on point-to-point links. On IXP, NAPs, /116s or even 112s, but basically the concept is really scaling the size of the subnet to the size of how many connections or how many hosts are going to be on that subnet. If it's a peering point, scaling and sizing the subnet accordingly and not using a /64. That's really kind of the bottom line. You're actually really scaling it so you have that hard limit, that hard ND cache limit, and that's really the ubiquitous standard for really operators all around the world. And that being said, and what this slide also talks about is really kind of the the next slide does. Let's go to the next slide, and that talks about kind of the final problem statement, and then I'm done with the deck. So this last piece here is really, the parity, the lack of parity that exists between SLAC and stateful V6 and static. So both static and stateful allow for basically any kind of mask, and any kind of mask, as I've stated, in the slides earlier, is used really ubiquitous standard across the globe. Operators use any size mask, but SLAC really has that really legacy 64-bit boundary that's existed from day one. So what that does is it does hinder operators from actually doing you're stuck with that 64-bit boundary. So, and it's really the fear of having any device that's SLAC that ends up being on that same subnet, would not work. So you're basically stuck at that 64-bit boundary that you can't do. And this is really this could apply to data centers as well as access, that you really cannot do any variable length masking. You can't do a longer prefix, basically. That you're basically hampered, that any DHCP V6 that's deployed really anywhere by any operators, you're really using only a 64-bit scope. And then same with static. Any static, so any subnet that has a mix, and you've got to account for the mix, that you're really any host subnets that are deployed by any operators, it's really a 64-bit, and there's really no choice, and it's really just due to the fact that that fixed boundary really hampers that ability to do longer subnets. That's all.
Lorenzo wants to get a word in.
Okay, sure.
I wanted to say one slide back. You're saying that you could just size your subnets for the specific number of hosts that are on the subnets. I'd like to point out that for general purpose hosts, like presumably this laptop that you have on the slide, the best current practices in RFC 7934 say that it's recommended that network operators allow devices to hosts to form as many addresses as they want. So what this means is you can't say I'm going to have 8 laptops on this subnet and assign us 125, because the best practices say that those laptops should be able to form more addresses. This is one of the reasons why also that document, the best practice, recommends against running a DHCP6 only network. So I just wanted to point that out. So there are best practices that say don't do this. Just wanted to point that out.
Yeah, Lorenzo, so just to that point, I think that you had mentioned, when they're doing in that best practice, like you had mentioned, it's a /125, you said. So the subnet size would be a /125, you said, or?
No, I think when you talked about the slide, you mentioned that you proposed a way, an addressing scheme where you would size the subnet as a function of the number of hosts. So if you had, for example, 8 hosts, it would be 125, right?
Right, but I think most of infrastructure. For infrastructure, I think for host subnets that have end hosts, that has been fixed at /64 just due to the boundary limitation. So I think any end host like Windows, PCs, or servers, I think really that's kind of been fixed at the /64, but it's really been infrastructure. Anything that's infrastructure, routers or switches.
Yeah. I understand. So if general purpose hosts are out of scope, then yes, that makes sense.
Right. Yeah. And that's something that I think I'm mentioning, that if the standard would allow like variable length, like longer masks, then it could be different. But because the standard has that fixed 64, you can't really change that. Everything has to be 64 for hosts, for end hosts only. Infrastructure can do whatever they want. So for network providers, routers, and switches, we can do whatever we want. But it's really just those host subnets are fixed at that 64, and there's really nothing you can do about that unless the standard changes. You agree with that, Lorenzo? Sorry, I can't hear you.
Now, the fact that there's not just a standard, but there's actually a recommendation not to do what you're proposing. So I just wanted to point that out.
Yes, but I haven't read that RFC, but is that actually they're proposing that for host subnets or actually infrastructure as well?
I think you already said for infrastructure you can do whatever you want, right? So
yeah.
So if you're suggesting changing this 64-bit boundary limitation, then you ought to consider that there is a best practice that says allow hosts to form as many addresses as they want. So
right. I mean that's true. That's true.
Okay, I have a feeling this is a conversation that could go on as long as we want to let it happen. So I would suggest that at this point we close the meeting and take it to the list.
That's good.
And now, Ron, that was our last presentation, correct?
That's right.
Okay, then I think we're done. So thank you very much.
Take care, everybody.
Take care. Thank you. All right. Wow, this is definitely slideshow. Now, that was that. Overall. Come on.